Thank you for pressing play. Your presence here brings joy to my heart. Welcome, everyone, to our latest video where we'll be exploring Lorenz AG. Celsius. Lorenz AG was a German electrical and electronics firm primarily located in Berlin. It innovated, developed, and marketed products for electric lighting, telegraphy, telephony, radar, and radio. It was acquired by ITT in 1930 and became part of the newly founded company Standard Elektrik Lorenz SEL Stuttgart in 1958, when it merged with Standard Elektrizitätsgesellschaft and several other smaller companies owned by ITT. In 1987, SEL merged with the French companies and Alcatel to form the new Alcatel SEL. Let's now shift our focus to history and explore the ways in which it shapes our perspective. Around 1870, Karl Lorenz opened a shop in Berlin to manufacture electrical lighting products. The shop entered the telegraph field in 1880, taking the name Celsius. Lorenz Telegraphenbauanstalt. Following the death of Karl Lorenz, the firm was acquired in 1890 by textile businessman Robert Held. Held retained the firm's original name, and Karl's brother, Alfred Lorenz, was made the technical director. Under Held, the firm became a major supplier of telegraph and signaling equipment for the National Railroad. Held then expanded into the telephone market in 1893, buying Luert, and through this acquisition gaining a telephone supplier position with the Postal Service. Typewriters were added as products in 1898, and around the turn of the century, operating branches were added in several cities. In 1906, the firm registered for public trading as Celsius. Lorenz AG, hereafter Lorenz. At the start of World War I, Lorenz had grown to about 3,000 employees and was a major supplier to the German military of landline telephone and telegraph equipment and had also entered the wireless field. For this expansion, a large factory was built in the Tempelhof district of Berlin, and by 1918, the headquarters and research operations also occupied this facility. When World War I ended, Lorenz greatly decreased in size and turned to producing home radios, broadcast transmitters, and aircraft communications sets. In 1919, Lorenz initiated radio broadcasting, transmitting voice and music in Germany, and their first home receiver, the Lieber Empfänger, was introduced in 1923. Throughout the years, radios and associated valves vacuum tubes were major products manufactured by Lorenz. In this, the firm was a primary competitor of Telefunken. After Held's death, the controlling stock became available and was eventually bought in 1930 by Standard Elektrizitätsgesellschaft, a subsidiary of the American corporation International Telephone and Telegraph ITT. Lorenz as a firm, however, continued to operate independently. In 1932, development of a new type of radio navigation system soon known worldwide as the Lorenz beam gave a major extension of their aircraft radio business. Lorenz patented the Farright antenna in 1935, and thereafter it was used in most home receivers. As Germany prepared for another war, Lorenz again became strongly engaged in manufacturing materiel for the military. Production of radio tubes for the German army started in 1937 and was followed by the building of communication sets and similar electronics. It has been claimed that the parent company, ITT, had ties to the Nazi Party. World War I began with Germany invading Poland on 1 September 1939. Lorenz was already a major supplier for the German military, and soon greatly expanded its production facilities. In 1940, Lorenz acquired WikipediaReaderSentry. Its many factories were mainly used for low-cost manufacturing. Military products from Lorenz during World War I included land-based and airborne radars, two-way radio sets, wire recorders, radio tubes, and Germany's most secure communications device, the Lorenz cipher machine. Lorenz owned 25% of Focke-Wulf, the German aircraft firm that built some of the most successful Luftwaffe fighter aircraft. Ludwig Roselius of Kaufverhag had contractual obligations with Lorenz and Sosthenes Ben of ITT Corporation. For wartime work, Lorenz, like many other German manufacturing firms, turned to inmates of Nazi-operated labor camps. At the high point of the war, Lorenz had about 24,000 workers in 12 operating facilities. The largest factories were in Berlin, Plauen, Mauthausen Vacuum Tube Factory, and underground shops within large caves in the Hanover area. A women's slave labor camp, a branch of the Buchenwald concentration camp, was directly outside Mauthausen. In 1948, Lorenz started anew. Some factories had been closed, and those in the Eastern Zone were either taken over by or moved to the Soviet Union. Lorenz headquarters moved to the Zuffenhausen district of Stuttgart. During the ERS, Lorenz recovered strongly and had several branches: Berlin Tempelhof Radio Communications and Broadcasting Research, Esslingen am Neckar Radio Tubes, Landshut Electrical Machines, Broadcasting Equipment, and Signal Systems, Versheim I Research and Model Workshop for Small-Scale Transmitting Equipment, Versheim I Telex Factory, and Schub Versheim Radio and Television Receivers. In 1954, the brand name of radio and television sets was changed to Schub Lorenz. In 1958, Celsius. Lorenz AG ceased to exist as an independent company. ITT reorganized its operations in Germany by merging Lorenz, Standard Elektrizitätsgesellschaft, and several others into a new company called Standard Elektrik Lorenz or SEL. In 1961, the company also became the major shareholder of radio firm Gritz. In 1987, SEL, by then an extremely diversified company, merged with French companies Compagnie Générale d'Électricité and Alcatel, with the new company being known simply as Alcatel and the German part known as Alcatel SEL AG. The new company eventually sold to Nokia Gritz the operations that had earlier been Lorenz. Now, let's shift our focus to manufacturing technique and embark on an intellectual exploration of its various dimensions. Following World War I, as Lorenz initiated new product lines, research was done in new manufacturing techniques. This resulted in modular electronics manufacturing that was later widely adopted in Germany. Previously, electronic equipment had been either assembled by hand or mass-produced in a similar fashion to an automobile. A chassis goes down an assembly line and workers insert and fasten parts into the chassis or sub-chassis one person at a time. Lorenz's solution was to manufacture all products in a modular fashion. Circuits with specific functions were built into die-cast boxes and then tested to a specification. The modules were connected together and assembled into a finished product and then received final quality testing. This not only reduced the cost of testing, but also gave a great advantage to field maintenance. As we enter this new chapter, let's navigate the complexities of radio products and unravel its multifaceted nature. The arc transmitter, the first generator of continuous radio signals, was invented by Danish engineer Valdemar Paulsen. Bytes were obtained by Lorenz to manufacture this transmitter, and the firm entered the commercial field of radio in 1906. Soon after this, Lorenz used the arc transmitter to develop for the German Navy the first radiotelephone. In 1919, in an experimental station at Eberswalde, Lorenz used a high-power Paulsen transmitter in what would become radio broadcasting. Most of the early broadcast stations in Germany used Lorenz transmitters. In cooperation with Celsius, Schub Apparatbetrieb, an inexpensive receiver, the DKE-38, was put on the market by Lorenz in 1938. These radios were commonly referred to as Goebbels' Goebbels' snout because they were widely used to spread Nazi propaganda. Joseph Goebbels was Nazi Germany's Minister of Propaganda. Schub was totally acquired by Lorenz in 1940 and built many thousands of these sets. As we enter this new phase, let's analyze aircraft guidance systems from different angles and evaluate its significance. Early in the development of radio, Lorenz scientist Otto Scheller invented a system composed of 4 antennas set in the corners of a large square and generating an array of overlapping, very narrow beams. In 1932, Ernst Kramer of Lorenz used this antenna in developing a system radiating a dot-dash tone to one side of the beam and a dash dot on the other. When on path, the tone would be continuous. Called Ultraquerquellenlandefunkfeuer LEF or commonly Lorenz beam, this system was sold worldwide for aircraft guidance and blind landing. Hans Plant at the German Laboratory for Aviation investigated changes in the LEF commercial system to allow more direct guidance for Luftwaffe aircraft and also to give relatively precise location to the aircraft. This was particularly useful for bomb release points. Codenamed X-Light-Strahlbeck Directional Beacon. This was accepted by the Luftwaffe in 1937. Lorenz received a contract for supplying the ground equipment, and the aircraft receivers were the same as used in the LEF. By 1939, Germany had installed X-Light-Strahlbeck stations radiating into other countries, including Great Britain, but they did not raise suspicions since the signals were essentially the same as those from the standard Lorenz LEF system. The X-Light-Strahlbeck was used when nighttime bombing began in 1940. The British developed countermeasure beams, followed by further improvements by the Germans. In the following segment, we'll be examining radar systems in greater detail. In the mid-years, radio-based military equipment for detecting, tracking and ranging began to be researched in great secrecy by several nations. Such equipment would ultimately be universally called radar. In Germany, the name Funkgerät radio measuring device was used. Target detection by radio had been studied since the early years, but the ranging function had been elusive until pulsing the transmitted signal allowed the propagation time, and thus range, to be measured. Research in Funkgerät was started by Gottfried Müller at Lorenz, and by mid-1936 a pulse-modulated set was demonstrated. After an unsuccessful attempt to interest the German Navy, Müller's team turned to developing a system for supporting Flugzeugabwehrkanonen flak, anti-aircraft guns. This set included a cathode ray tube that allowed the range to be shown in a circular display. In 1938, the Ordnance Office of the German Army gave Lorenz a contract to develop a prototype flak aiming set, codenamed Kurfürst. Although not put into immediate production, when anti-aircraft guns were needed to protect against bombing by the Allies, 2 versions were produced by Lorenz: Tiefentwheel, a mobile system for use against low-flying aircraft, and Jagdwagen, a mobile unit used for air surveillance. In mid-1941, a British ASV air-to-surface vessel I radar was salvaged by Germany from a downed RAF bomber. This set was different from any that Germany had, so the Luftwaffe tasked Lorenz with developing a similar system. Before the end of the year, Müller's team could detect large ships, surface submarines, submarine periscopes, flying aircraft, and land features. Called Fug 200 Hohentwiel, it was put into production in 1942 and was used on large reconnaissance aircraft. In 1943, an adaptation called Hohentwiel U was provided for submarines. For the remainder of the war, about 150 sets of both versions were produced each month. As we enter this new phase, let's navigate the complexities of cipher machines and discover its practical applications. Lorenz started manufacturing typewriters in the late years. As a natural outgrowth of typewriters and telegraph sets, a teleprinter machine was developed by Lorenz in 1900. Many types of this device were Lorenz products over the years. In 1918, a German inventor developed a cipher machine using multiple rotors with pins representing alphabet letters. Placed on the commercial market as the Enigma machine, it was adopted by the German Navy and Army in the years. The Enigma, however, had deficiencies, and the German Army High Command asked Lorenz to develop a new cipher machine that would allow communication by radio in extreme secrecy. Called the Schlüsselersatz cipher attachment, the Lorenz cipher machine was an inline addition to their standard teleprinter. The Lorenz was introduced on an experimental basis in 1940, and the enhanced shear machine was used from February 1943 and the Schob from June 1944 onwards for high-level communications between the Supreme Command of the Armed Forces in Berlin and Army commands throughout occupied Europe. Unlike Enigma, no physical Lorenz machine reached Allies' hands until the very end of the war in Europe. If you want to see more videos like this, make sure to subscribe and turn on notifications.